Geometry lesson 1-2. Continuing with some more vocabulary, and then I think most of it will make sense for you if you kind of get some explanation for this. One of the things that's difficult about a few of these vocabulary words is the concept that you really need to conceptualize and visualize what's taking place. For example, one of our first definitions, point, is somewhat hard to grasp because it has no dimension and no size, which is really strange because we're used to going, what do you mean? There's a point right there. And that point definitely has size. It definitely has dimension. We have to represent it some way. We have to represent the point in a way that we can manipulate it and deal with it. But in reality, that point is actually covering more than one spot. If we had the ability to zoom in with like a microscope, you would see that the dot is actually much bigger. Now, it isn't much bigger in reality, it's that small, but it's covering more locations. If we had the ability to keep getting smaller and smaller and smaller, we'd actually get more exact with the location of the point. But then we wouldn't even be able to see it. And even then, if we could zoom a little bit further, we'd notice that it was overlapping a few more other spots. So it's really a tough idea to think to ourselves, what do you mean? That has no size. That has size. Well, it has size for us to see it. But in reality, if I were to put my finger right here, my finger is touching more than one space, which means I'd have to be able to get tinier, but it's still touching more than one space. So it's sort of hard. But nonetheless, this will be the symbol if we see something like this, and then you'll usually put a letter by it. So this would be like point R. So it's represented by a small dot. A line. And a line, you're going to extend in one dimension. When you watch a movie, movies are two-dimensional, unless you go see the three-dimensional movies. But they're two-dimensional because they have the height of the movie screen and they have the length or the width of the movie screen. But either way, that's one dimension and a second dimension, giving you a flat screen that's two-dimensional. When it feels like the movie is coming at you, that's why it becomes three-dimensional. So here we have a line that extends in only one dimension. If I'm talking about the movie screen, only this part right here would be one dimension. This is very similar to a line with the idea that it must continue from this point on and from here on forever. Now, this doesn't have to be just here. That's also going in both directions forever, and it's in one plane, or one, in this case, dimension. This also. All of these are examples of a line going in one dimension as long as it goes on forever. So it's usually straight with two arrowheads indicating the lines could go without end. So you'll notice that you have an arrowhead here and an arrowhead here. Now you'll typically have some dots on here. Maybe one there and maybe one here. It really doesn't matter where they are, but then we'll label them A and B. And now we have the line AB. If there happens to be a third point, that's okay. This could be C and this could be D. But we don't need to label it as all of that when we go and we abbreviate it with this symbol. We can just say line AB. We aren't going to write line ACDB. We're not going to put every single part out there. We're just going to use two of them. Now because it is a line, it actually goes through C and continues. You could say it's line AC. Or you could say it's line AD. Because it does go from A through D and through A in both directions forever. So you do have different ways that you could express it. If you want to call it line BD or BC or BA, that's fine too. But it has to have 2 points that it continues through forever, and it must be one-dimensional. Now when we start talking more three-dimensional objects, things will change. But here we have a two-dimensional object, which is a plane. Now, probably the best example of a plane for us, because it does go on forever, would be like the tabletop, the top of a table. Because I know that it doesn't go on forever, but it's at least extending in two dimensions. So you would have this side of the table, and it would go this way forever. And you would have over here this side going forever. And you'd have this side going forever. And you'd have that side going forever. So it's extending in all areas as thin and flat as possible. But it's never going to end. So here we have a parallelogram, which represents like a flat table, and this arrow is saying that that side really goes on forever, and this side really goes on forever, etc., etc. So envision this whole smartboard. If the smartboard just went on forever up, and went on forever below, and went on forever that way, and this way, then it would be considered a plane. It requires 3 points to make a plane. 1, 2, 3. 2 points is not enough to make a plane because 2 points would really be one-dimensional. As long as there's a minimum of 3, then you can have a plane, which is exactly why a tripod works the way it does. You could make a quadpod or a pentapod. You could make some sort of a camera equipment tool that has more than 3 legs, but you'd be increasing your materials and the weight, and it just requires 3 to be stable. That's the minimum number you need for stable without having to balance. So a plane has to have 3 points, and you could label them as well. A, B, C, if need be. Alright, a line segment. Most times when we talk about in class, oh, draw a line on your paper, we're actually drawing line segments. If you actually said to someone, can you locate the lines on your paper? The line segments are really what you're talking about, because if you recall, in order to be a line, it must continue in both directions forever, and you can't draw that on your paper. You can't draw something that continues on forever. So you're really dealing more with line segments. So they're similar to a line, but they don't have arrows. And they don't have arrows because right here and right here are your spots where it starts and stops. Or maybe it starts a B and finishes an A. But you would use a line segment symbol instead of the arrows. So make sure you pay attention to this symbol versus one of these symbols. Notice the arrows. Once again, it is a one-dimensional figure. Opposite rays. 2 rays that share an endpoint, and they must be coplanar. So, in this case, they're going in opposite directions. Here's the one point they share, and they're going opposite of each other. Alright? They're in the same plane, so it's okay. This whole board is really a plane. So if I have this dot, and this line goes that way in the plane, and that line goes that way in the plane, it's still going to work. If you pretend that my finger is the point, and then this represents the ray going that way, and the ray going that way, then no matter where I have this, those would be considered opposite rays, because they're in the same plane together, going in different directions from that one point. Collinear. If you had a co-counselor or a co-teacher, it would be somebody that was working with you or alongside you. Points that lie on the same line are considered to be collinear. Linear means straight line. If you take off the AR, you're looking at line, co-line. So we want something that is collinear. All of these points are lying on this same green line, therefore they would be considered to be collinear. They're all on the same line. As soon as this point's right there, these points are collinear, but not with that point. It's not collinear with the rest of them because it's not on the green line. Coplanar, very similar, except now we're dealing with the plane again, which is more of a two-dimensional object. Points that lie on the same plane would be able to fit on that same flat object. If there was one more point up here floating above, it would not be coplanar with the others. All right? You could have something that's coplanar with 1 or 2 of these, but not coplanar with the rest. In order for them to all be coplanar, they must be on the same flat object. Or flat, I guess, really more space, not an object. And our last definition, intersection. A set of points where the figures have in common. Anywhere they come in contact. When I actually put this meter stick against here, that is the point of intersection. And in fact, this whole edge was touching the board, which means all of those points are intersection points. Right there. So there's more than just one spot. It would actually be a whole bunch. If it comes in at an angle, maybe it just touches at that one corner. It's still an intersection spot. If I put the whole board, the whole meter stick across, now it has quite a few points of intersection. That whole edge. Any of those points that they have in common are going to be considered an intersection point.